Welcome to Mars Saga, your gateway to the Red Planet. Subscribe now and join the journey.
Hey there, space explorers. Welcome to Mars Saga, the place where Mars isn't just a planet, it's a silent mystery that's been watching us for billions of years. In today's episode, we're diving into a discovery that shook scientists to their core. No water, no signs of life, but something far more mysterious. Rocks that whisper the untold history of an alien world. These aren't just stones, they're Martian secrets, written in layers and locked in time. Each crack, each shimmer tells a story millions of years old. So stay till the end, because what you're about to hear might just change everything you thought you knew about Mars. Let's begin and dive deep into the newly discovered Martian rocks. And hey, if you love exploring the unknown, don't forget to subscribe to Mars Saga, where curiosity meets the cosmos. In February 2024, NASA's Perseverance rover, or Percy as it's fondly called, touched down on the rugged surface of the Jezero crater, a site chosen for its rich geological diversity. At first, it was thought this place held traces of ancient rivers and lakes. But what Percy found wasn't water. It was something buried even deeper, stories carved in stone. The area is now famous not for ancient life, but for uniquely layered rocks that tell a complex story of volcanic fire, chemical storms, and the relentless shaping of a world we barely understand. These rocks, rich in silica, magnesium, and iron-bearing minerals, formed through thermal and chemical transformations deep beneath the surface, each one a fossil of Mars's inner heart. Percy's mission was simple but bold. Uncover Mars' hidden geological history. And if there was any place capable of holding that story, Jezero was it. You see, certain Martian minerals like olivine and serpentine record the planet's internal heat and chemical changes, almost like a diary written by the crust itself. By studying these, scientists can trace how Mars cooled, solidified, and became the cold red desert we see today. On Earth, geologists study similar rocks in volcanic deserts and impact zones to decode the birth of worlds. For Percy, Mars was no different, a vast frozen archive waiting to be read. Then came the discovery. One day in July 2024, while exploring the edges of the ancient Nerteva Vallis Channel, Percy's cameras spotted something strange. A rock, gleaming faintly under the thin sunlight, that didn't match the surrounding terrain. NASA scientists called it Chayava Falls. Two of Percy's high-tech instruments, Pixel and Sherlock, scanned its surface. What they found made jaws drop at mission control. Finely layered sediments, complex mineral bands, and deep within them, the chemical fingerprints of time. On Earth, such structures often preserve traces of ancient reactions, silent witnesses to processes that happened long before life began. But on Mars, this was uncharted territory. The rock was rich in carbonates, phosphates, and iron oxides, arranged in delicate circular patterns. Scientists nicknamed them leopard spots and poppy seeds. Tiny, intricate, and mesmerizing, each pattern smaller than a grain of sand, yet bursting with clues. The lighter inner part of each spot matched the host rock, but the darker rim was enriched with iron and magnesium, hinting at long cycles of oxidation and mineral layering deep underground. In other words, this rock had lived through fire, pressure, and time. It was proof that Mars's interior was never truly dead. Percy's readings also revealed carbon-bearing minerals, but not biological ones. Instead, these pointed to chemical evolution, the slow dance of minerals reshaping themselves under heat and pressure. Scientists now believe this specimen once sat in an ancient hydrothermal system where hot, mineral-rich fluids circulated through fractures in the bedrock. On Earth, such systems form rare crystals in metallic veins, the fingerprints of a planet's restless heart. On Mars, they reveal something even more profound, a glimpse into the engine that forged its crust. At the center of this mystery are two minerals, vivianite and greigite. Vivianite is an iron phosphate. It forms in areas where metal and heat meet. On Mars, it likely appeared when iron and phosphate compounds reacted deep underground, perhaps during a volcanic or impact event. Freshly exposed, it glows a pale blue, like frozen light. Greigite, on the other hand, is an iron sulfide mineral that records a planet's magnetic and thermal history, like a memory chip from deep time. Together, they act as natural time capsules, preserving the evolution of Mars from a fiery infant world into the cold desert we know today. When freshly exposed iron met phosphate under the right chemical tension, vivianite was born. When sulfur and iron collided in ancient reactions, greigite took shape. No life, no biology, just pure geochemistry. But that raises a question. If no microbes were involved, what then sparked these reactions? One leading theory points to intense volcanic pressure beneath the crust. Sulfur gases from ancient eruptions could have seeped into fractured rocks, reacting with iron as they cooled. Over time, this created perfectly layered mineral structures, almost like fingerprints left by Mars itself. Each mineral tells a part of the same story: heat, pressure, change, silence. Mars may look quiet now, but once it was alive in a different way. Not with creatures or plants, but with molten breath and geological storms that rewrote the surface again and again. And somewhere beneath the dust, those old forces may still linger. So, when you look at those lonely red hills through the eyes of perseverance, remember, you're not just seeing a planet, you're seeing the memory of a world trapped inside the stones. This discovery didn't prove alien life, but it gave us something almost as extraordinary: a key to Mars' hidden heart, the realization that the red planet is not dead, only waiting to be read. And that, explorers, is why Mars continues to call us back. Every crater, every ridge, every whisper of dust holds the same promise that we're getting closer to understanding the planet that might one day be our second home. Thanks for watching Mars Saga, where the mysteries of the red planet are never silent. Until next time, keep your eyes on the stars and your curiosity on Mars.